All right, in this video we're going to write the ionic and net ionic equations from a completed double replacement reaction, a precipitation reaction. We previously predicted the products in this reaction between soluble lithium hydroxide and soluble lead nitrate. We showed that the lithium nitrate and lead hydroxide that are formed are aqueous and insoluble. So the lead hydroxide forms an insoluble precipitate. In solution, though, keep in mind that the aqueous salts, for instance the lithium hydroxide, is actually separated ions that are surrounded by water molecules. So we can represent the lithium hydroxide as this, showing the separated cation lithium with its aqueous shell of water, and then the hydroxide with its aqueous shell of water. Furthermore, the lead nitrate, PbNO3 Okay, this is also can be represented as these separated ions in solution. Right, and notice that I put a 2 in front of the nitrate because when that salt dissolves, there are 2 nitrates for every 1 lead cation. And so in the completed equation, I write 2 in front of the NO3 minus. So we can represent this in our equation above, right? We can go ahead and represent the lithium hydroxide as the free ions, as shown, and do the same thing with the lead nitrate. Oh, and just to mention, since there are 2 Li is a 2 in front of the lithium hydroxide, we need to put 2's, right, in front of both the lithium and the hydroxide in the separated ions. And then we can write the lead nitrate as shown, Pb2 plus and 2 NO3 minus. And this, of course, goes to products. Now, one of the products is soluble, the lithium nitrate. And so since it is a soluble salt, it can be represented as this, right, the free ions. And so we'll transform that up into the equation above, lithium and nitrate. So now we've basically taken the empirical formulas for those salts and the aqueous salts and shown them with as separated ions, which is a little more physically realistic. Of course, the lead hydroxide is a solid and therefore does not separate. The lead and the hydroxide ions are tightly bound and not separated by the water. And so we just move that down into our equation below. Like so. This equation is called the complete ionic equation. Everything that can be shown as free ions is shown as free ions. So anything that is a soluble salt should be re-represented as its free ions, as we've done in this one. Notice that the 2's in front of the lithium hydroxide and the lithium nitrate in the top equation, the molecular equation, are transferred down in front of the ions. Right, so this 2 is transferred down in front of the ions in the net ionic equation, and the 2 here is transferred down to both of those. You'll also notice that there are some common ions on both sides of this equation. For instance, the 2 lithium plus ions appear on both the reactants and the product side, and so essentially nothing's happened with lithium. And the same can be said for the nitrate, right? NO3 minus appears on both the reactants and product side, and therefore nothing really happened with nitrate. So if we want to just show the sort of active players in the equation, what we do is cancel out the like ions on each side and produce what is called the net ionic equation. So there's the complete. We're going to now find the common ions on both sides, the lithium and the nitrates. We'll cancel those and rewrite our equation with just the remaining, the hydroxide and the lead, which forms lead hydroxide. And this this equation, which just shows sort of the active ions, is called the net ionic equation. So we have three equations, the whole, or sometimes called molecular, although that's not a very good name since these are all our ionic compounds. But the top complete equation, then we have the complete ionic equation, the middle one that shows all of the ions that are in solution. And then if we just want to show what is really interacting, the net ionic equation, the third one.